Hello everyone. Today we will be talking about counting method and conditional probability. Now we need counting method to figure out the different arrangement of inputs or the different sequence of processing of inputs. So for example, if I have a system, that consists of many subsystems to process certain input. Now let's assume this subsystem has n1 different way of processing the input, then this subsystem has n2 different way, and this subsystem has n3, and we may have n4, n5, and so forth. So then how many way can an input be processed to give us a certain output? Well, let's see. In the first stage, there are n1 different way. Then in the second stage, there are n2 different way of processing. And in the third stage, there are n3 different way. So one way to process the input through the whole system here is this way with this one, with this one. This method with this one, then this one. This method with this one, and this one, and so forth. So there are n1 time n2 time n3 different way. So if n1 equal 3 and this is 4 and this is 5, then there are 3 times 4 times 5, that is 60 different way to process the input. Let's look at this example. When ordering a certain type of computer, there are 3 choices of hard drive. So let's say hard drive here, 3 choices. So that's N1. 4 choices for the amount of memory. So memory, there are 4 choices. 2 choices for video card. So video card, 2 choices. And 3 choices for monitor. In how many ways can a computer be ordered? So there are 3 possible different hard drive. 4 different memory. So each hard drive can have 4 different memory. So if I say this is, for example, hard drive 1, hard drive 2, hard drive 3, then the memory here, there are 4 of them. So it can go, hard drive 1 goes with this one, or with this one, or with this one, or this one. So there are 4 possible way. And same thing for hard drive 2 has 4 possible way. Then we have the video card. So the total different way you can structure your computer or build your computer will be 3 times 4 times 2 times 3. So this is 72 different way you can construct your computer. In communication, sometimes you can think of this one as symbols, how many way you can arrange the symbols to form a word that you will be transmitting. Okay, now there are 2 different ways we can count all the possibility of constructing a pattern from given objects. So I have here objects 1, 2, 3, 4, 5, 6, and you want to construct a word or a system or a pattern out of these objects. So the system could consist of 3 different stages. So how many way you can construct this system that consists of 3 stages from these 6 objects or 6 subsystems. Now there are 2 different ways to calculate the number of arrangement. One is permutation, when order matters, and the other one is combination, when order does not matter. So let's focus first on permutation. So in permutation, let's take a simple example. If I give you a population or objects like, let's say, letters A, B, C, and I ask you how many ways you can arrange these letters, and in this case order matter. So why order matter? Because I can arrange them in this way, A, B, C, or I can arrange them back, B, A, C. And A, B, C, the meaning of it could be the TV channel back, a different word. So order really matter, even though this arrangement has the same letter or the same objects. So if I have 3 objects, then there are possibility I can arrange them A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. So there are 6 possible ways to arrange 3 objects in different way. In general, here n equal 3. So these 6, we arrange it easily because they are 3 objects only, but it is 3 factorial. And 3 factorial means it is 3 times n minus 1. In this case, 3 minus 1 is 2 times 1. So in general, n factorial equal n times n minus 1 times n minus 2 all the way until you get 1. So if you have n object, how many ways you can arrange them and order matter? It's n factorial. Okay, if you have a population with 4 elements and you want to construct words of 2 letters, and the population could be A, B, C, D, and here order matter. So we can start A with the B, then A with the C, then A with the D. So that will be A with the B, A with the C, A with the D. And then B with the A, B with the C, B with the D, then C with the A, C with the B, C with the D, and D with the A, D with the B, D with the C. So there are 4 here and 4 here and 4 here, total 12 different ways. Now, it is simple to arrange or calculate how many ways I can arrange a small number of samples like N4 with a pattern that consists of only 2 objects, k equal 2. But what if n is very large, like n is 100 and k is 20? There is no way I'm gonna list all possible patterns. So there must be an easier way to figure out this number. So let's look at the same example here again, which is you have A, B, C, D, 4 objects, and I want to construct a pattern that consists of 2 objects. So the first position here, you have 4 possible choices. You have all the objects here, A, B, C, D available. So there are 4 different ways I can put in this position. The second position here, well, I already took 1 object. It could be the A or the B. So there are only 3 objects remain in this population or available. So there are 3 possible ways left. So then that will be 4 times 3 is 12. So 4 is n, since my population consists of n. The second choice has n minus 1. And if my pattern need to consist of 3 elements instead of k equal 2, then it will be n minus 2 and so forth. So if I look, let's say k is 2. This minus 1 here, it's just k minus 1. So 2 minus 1, you get the 1 here. So the general equation really, it is n times n minus 1 times n minus 2 all the way to n minus k plus 1. So the 1 here, we said it's just k minus 1, so it will be minus k plus 1. So this is a general formula to calculate how many ways you can construct a pattern of k element, and you can choose this k element from a population that consists of n elements. And we can rearrange this one here to equal n times n minus 1 times n minus 2 all the way to n minus k plus 1, n minus k all the way to 1. If I do that, then I have to divide by n minus k factorial. So this n minus k factorial will cancel all these elements here that follow. Then this one here and this one here will be the same. And this, I can write it as the numerator is just basically n factorial, and the denominator is n minus k factorial. And that is the number of patterns you can construct if you have n object and the pattern consists of k objects. Then it will be n factorial over n minus k factorial. And this is this one here. The number of permutations of k objects chosen from a group of n objects is this one. Now let's look at this example. 5 people stand in a line at a movie theater. Into how many different orders can they be arranged? So you have a population that consists of n equal 5, and you want to arrange them in this pattern, and order matters, so that will be n factorial. So that is 5 factorial, and this is 5 times 4, 20, times 3, 60, times 2, 120, times 1, 120. Let's look at the second example here. So you have a population that has 5 guards, guard 1, guard 2, guard 5. And there are 3 lifeguard stations. So we have here 3 stations. Station 1, Station 2, Station 3. In how many ways can 3 lifeguards be chosen and ordered among these 3 stations? So this station, Station 1, has 5 possibilities. So here it has 5 choices. I can choose any one of these 5 guards. So if I fill Station 1, now Station 2 has only 4 possibilities because one of the 5 already went to Station 1. Station 3, there are only 3 guards left. So it has only 3 possibilities. So that is 5 times 4 times 3. So that's 60. Or we can just use this formula here. So that's n factorial. I have 5 factorial divided by n minus k, 5 minus 3 factorial. So that's 5 factorial divided by 2 factorial. So that is 5 times 4 times 3 times 2 factorial. And here is 2 factorial. These cancel these. So I have 5 times 4 times 3 is 60. Now, combinations, order does not matter. In a cases, if I choose John then Smith is the same as if I choose Smith first then John. So the order here does not matter. And I have here a population that has n objects, and I want to form a subpopulation with k objects. How many ways I can construct this subpopulation or this event? And in this case, order does not matter. A, B, or B, A are the same. I don't count them twice. Now, for this, it will be this one. N factorial divided by n minus k factorial divided by k factorial. And you can think of this one. If I take k object here, what is left here is n minus k. If order doesn't matter and I have a population with n object, then n factorial, that's how many ways I can arrange them. But now order does not matter, and I can arrange these 2 subpopulation k and n minus k in this different way. That will give me the number of combinations of k objects chosen from a group of n objects. And this is the formula we use. So when order does not matter, then use these equations. When order matter, then use this equation. N factorial over n minus k factorial. Now there are a scenario where you have object or a population that has n object and you want to divide them to a subgroup, such that this group maybe consists of k1 object, this is k2 and k3. And if I add k1 plus k2 plus k3, it will equal n. Then how many ways I can construct this sub-event or these sub-objects combination of n object? The answer to it is this one. As long as k1 plus k2 plus k3 equal n. And that's the same thing. This is just really a special case of this one. In this one, I'm dividing the population n to really subpopulations. One has k, one has n minus k. You can think of it this way. This one, I'm actually dividing it to r subpopulation, not just to 2. So let's solve this problem. At a certain event, 30 people attend and 5 will be chosen at random to receive door prizes. The challenge about these problems is to decide, does order matter or not? So do you use permutation or do you use combination? So let's see here in this example. At a certain event, 30 people attend, so n equal 30, and 5 will be chosen at random to receive door prizes. So 5 will be chosen, so that's k equal 5. So the order in which people are chosen does not matter. If I chose Ali, John, Samantha first, or Samantha, John, Ali, it does not matter. They will just receive the same prize. So how many ways out of these 30 people, 5 will be chosen? So that is a combination. So it will be n factorial over k factorial n minus k factorial. So that is 30 divided by 5 factorial. 30 minus 5 is 25 factorial. And you can use a calculator to solve it. It will be 30 times 29, 140, 20,506. Let's look at this example. A company has hired 15 new employees and must assign 6 to the day shift, 5 to the graveyard shift, and 4 to the night shift. In how many ways can the assignment be made? So now we have n equal 15, and I'm dividing them into 3 subgroups. The first one, K1 here, is 6. The second subgroup, 5. And the third group, K3, is 4. So 6 plus 5 plus 4, that's 15. So how many ways I can arrange it? Well, we're going to use this equation, n factorial, K1 factorial, K2 factorial, K3 factorial. So that will be 15 divided by 6 factorial, 5 factorial, 4 factorial. And this will equal 630,630. I will stop here, and next video will be about conditional probability and independence. Thank you for watching.